Okay guys, I want you guys to do this activity, very simple activity, but helps you guys learn about the concept a lot. So here the agenda is to understand a centimeter from the point of view of a meter and decimeter. So meter length, I hope you guys know about meter length. And decimeter is to do with 1 by 10th of that. Deci is to do with 10. So decimeter is to do with 1 by 10th. And exploring its size in a hands-on way. So we are trying to relate centimeter to meter and decimeter. That's the agenda. So meter is as tall as you guys, you can imagine that. So your height will be around, of course, you guys might be taller or shorter, but still you can imagine that a meter length is almost as tall as you guys are. So relating your height to a centimeter length is what we are trying to do. Okay, so I understood the objective. Material needed is very simple set of things. A strip of paper, a meter length, a measuring tape basically that will help you. You need to know what is a meter length, exact length. Then we need a scale and scissors, pencil, tape and worksheet or notebook for recording. The procedure is quite simple. All it has to do with folding. So fold the meter long strip into 10 equal parts. Mark the division. And then take 1 decimeter and fold it into 10 equal parts, mark the division, and so on and so forth. And complete the observation table. So let me show you guys. This is the entire procedure. I have a meter length paper. I need to fold it how? Fold it this way. First, I took the meter length. I folded it into 2 equal half. Now, again, I made a second fold. When you open it, I'll get 3 equal parts. So 1, 2, 3, 4 sections. I'll get 4 sections. Okay. Now, you have to take one end of the paper and fold it in such a way that, right, this is the tricky part. I'll explain why it works, but let me explain this way. So basically, actually, let me zoom in. See, basically, I took this end, say, for example, this end. Now, I'm folding in such a way that, okay, so I have one of those ends. I'm folding in such a way that this entire length, right? Okay, so if this is, say, 2 centimeter, this has to be 4 centimeter. So I'm folding in such a way that we have this relationship. Okay. So let me show this. This is the original length and you can see the difference, right? Can you see the difference? Okay. So basically I folded in such a way that I almost overlap with the original marking, original fold, but bit away. You can imagine that way. And this I'll explain in detail why this works and how to do this exactly. For now, just take it as, okay, I did that. I was able to successfully do that. So that the ratio is 1:2. I don't know if you guys understood that, but yeah, let me explain it in the next section, next video. Let's continue over here. So I did this and now I have 1 decimeter. So next I continue to, with that as the reference, I continue to fold, and finally I have one more fold left to get 1 decimeter or 10 decimeters actually. This is the last fold. So when we open it, we get 10 parts. So a meter length paper, I have divided into approximately 10 equal parts. 1, 2, 3, 4. Then 1, 2, 3, 4. And 1, 2. So 4 plus 4 is 8, 9, 10. So you can see that there are 10 equal parts. Right? And now we have a decimeter. So this is a decimeter. Each of this is a decimeter. So that completes our first step. Fold the meter long strip into 10 equal parts. Okay. So we have here 1 decimeter. So this is basically 1 by 10th of a meter. Can I tell that? Because I took a meter long paper and I folded it into 10 equal parts. So this has to be 1 by 10th. Right? 1 by 10th of what? 1 by 10th of a meter. This is equal to 10 centimeter or 1 decimeter. Again, these are just names. We just need to know this. So a quick question to you guys. How many decimeter makes up, as per this diagram, makes up 1 meter? Remember, one of this is a decimeter. So basically 10 decimeter makes up 1 meter. Do you guys agree? Right? Okay. I hope you guys were able to understand that. From 1, I went to 10 parts, 10 equal parts. That's all. That's all you need to understand mainly. I went from 1 length to 10 equal parts. Now we have to take 1 decimeter. That is, I have to take one of the small sections like this. See, I have cut that. Originally it was this. Then I cut one of it. And now I go through the same process with that small sheet of paper. So I try doing it. First I folded it in the middle and one more fold and I opened it. And you can see over here, I tried doing this step. Which step? This step. Wherein we have this, say this is the back. The back is folded in such a way that this back is double this section. So I try doing that. Can you see that? Try doing that. The first attempt I was not successful actually, honestly. But eventually I got it. Okay, kind of. Right guys. And so I did that folding. So basically, let me go to this explanation. I took one of this, divide it into 10 equal parts. So basically, if I did that, right, what will I get? So I get 10 parts of a decimeter. And so it will be 100 parts of a meter. Can I tell that? So each of this, if I divide it in 10 equal parts, so if I keep doing that, how many parts will be there? 100 parts. Let me show this. So I have a length. I divide it into 10 equal parts, right? So each of this is 1 decimeter. And I further divided each of this section. Let me zoom in. So I took up and divided into 10 equal parts like this. So 1, 2, 3, 4 like this. I divided in 10 equal parts. So overall, how many parts will be there? Can you see that? Overall, if I keep counting this way, how much will be there if I keep counting from left to right? If I reach the right extreme in this manner, how many parts will be there is the question. Yes, there will be 100 parts in a meter. And one of this part will be what? Yes, one of this part will be your 1 centimeter. So 101 centimeter makes up a meter. Very important conclusion. Okay. So basically, if this image happened to represent 1 meter, the distance between two red dots is 1 decimeter. And the distance between each of the small section is 1 centimeter. And that's how you get 1 centimeter from 1 meter. Okay, by folding into 10 parts and taking up one of that and folding it to 10 more parts. So let's verify this actually. So first thing first, this is our decimeter. Can you see that? It's up. This is the main paper. This is the middle folding. So one of this section from one end to another end. Can you see that? This is 10 centimeter. So 1 decimeter basically. I almost got it right. Right? Yeah. Next, this is me attempting. This is me being unsuccessful. But the second attempt was better. Not exact, but better. So this is my second attempt, and you can see that the very first fold is 1 short of a centimeter. Because of the folding, this happens. I can't explain it now, but yeah. 1 to 2, we almost got it right. 2 to 3, it's better. 3 to 4 centimeter, my marking is, it starts not to overlap. 4 to 5, it's getting worst. 5 to 6, kind of, it's a centimeter length. 6 to 7, kind of a bit more than centimeter. 7 to 8, a bit more than. And finally, 9 to 10, we can see we are pretty off. The folding is off. So this is how I can get a centimeter from a meter. Of course, our folding, there's a reason. The folding itself takes some thickness and it leads to this, So were we able to kind of successfully get a centimeter from a meter? That is something that you guys can tell yes or no. I won't comment on that. Now, let's look at some observation. Length of one segment in a meter strip after first set of folding. So what is the length? I can write either as 1/10 of a meter, or I can write it as 1 decimeter, or yes, I can write it as 10 centimeter of a meter. So this is what they're asking for actually. Yeah, from here to here, what is the length? We can call it as 1 decimeter or 10 centimeter. A second question is over here actually. Length of one segment in the decimeter strip in terms of centimeter, it is 10 centimeter that we saw over here. Number of centimeters in a decimeter. Okay, that you guys can see this and tell. How many centimeters are there? There will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I counted 10. So 10. Does the folding centimeter match the actual ruler's scales 1 centimeter mark? Almost. Right? I kind of got it. I was very happy to see 2 and 3 being right. Actually, 2 and 3 is the right benchmark. The initial folding, if it's right, means you kind of got it. The final folding, yeah, it will go bad for obvious reasons, folding reasons. But if not, yes, we got it right. And key takeaway. A centimeter is 1/100th of a meter. I hope you guys were able to see this. This I confirmed with this animation as well, right? And our decimeter is 10 centimeter and a meter is 100 centimeter. I hope you guys were able to conclude this as well. Try doing it. Take a scale. You should do this. So folding helps visualizing and creating an equal part and making measurement concrete. I hope it happens to you guys. Yeah, you can pause and have a look.